This is TK Academy, where the T and the K stand for Team Knowledge for architects and designers. This is one of our core competency courses, which is a back to basics learning subject, and the course is over the topic of landscape plantings. Through this course, we'll learn the differences between common and botanical names used for plants. We'll explain what the differences are between angiosperms and gymnosperms. Then we'll explain what the differences are between simple and compound leaves and identify different leaf arrangements. Finally, we'll explain what a tree caliper is the measurement of and describe the three methods of tree root packaging. Internationally renowned and professor of landscape architecture, Dr. Sue Ann Ware once said, "Landscape architecture used to be the parsley on the pig, the token decorative garnish around the building." What she meant by this is that landscape architecture should be more than just an afterthought, a greening of a project once it is completely built. Landscape architecture should be part of the whole project design and should be integrated from the very beginning of a project as much as possible. Landscape architecture is about providing design solutions, and it has had an impact on your experiences if you've ever been anywhere outdoors in the built environment. After all, the first experience of a building is always viewed through the landscaping. When we say that landscaping is more than just the parsley on the pig and the greening of a project, what are we saying that landscaping does for a project? We know that landscaping can influence the microclimate of an area. Trees provide shade and filter the wind. When properly positioned, trees can provide shade for a building during summer months and allow for sunlight to enter a building during the winter. Dense groupings of trees can be placed upwind of a location to significantly reduce the winds experienced on the site. Plantings mitigate soil erosion issues and minimize stormwater runoff from a site. Ground covers provide cooler ground surfaces instead of having hot reflective surfaces such as concrete, asphalt, and rock, which lead to what is known as the heat island effect. Landscaping can create natural habitat for living creatures such as birds and insects. Landscaping can also be used for visual screening to obscure areas that are not visually attractive, or positioned below windows and around areas to provide deterrence and security. And of course, there is the aesthetics, which is more than just the look of an area, but how one experiences the site and how the landscaping becomes an integrated part of the whole project experience. Plants are one of the primary materials that are on a landscape architect's palette. They are not botanists or horticulturalists, but landscape architects must be familiar with and be knowledgeable of the various plant species typically used in landscaping. So we are going to learn about the process and methods of identifying different types of plant species. We'll discuss naming conventions and plant classifications. We'll learn about the different types of leaves, the parts of a leaf, the leaf shape edge, and leaf arrangement. Finally, we'll discuss trunks, branches, stems, and bark. By learning these different characteristics of a plant, we will learn to be able to identify the different types of plant species commonly used in landscape design. There are two naming conventions that are used for plants, a common name and a botanical name. The common name can greatly vary depending upon region or even upon the individual. An example of a common name for a particular type of tree is honey mesquite. Because there is so much variety in what the common name may be for a plant, we also have botanical or scientific names. The botanical name will use the binomial or Latin nomenclature. The first word is genus, and the second word is species. So together we refer to the plant by its genus-species combination. When the botanical name is written, the genus is always capitalized, species is always lowercase, and both words are italicized. For the example of the honey mesquite tree, its botanical name is Prosopis glandulosa. Varieties are when mutations occur in nature, and they are denoted after the botanical name by VAR, which stands for variety. This is followed by a descriptor or name, as in our example, Prosopis glandulosa variety Torreyiana. Cultivars are when mutations are intentionally bred into the plant, and they are denoted by the letters CV at the end of the botanical name, followed by a descriptor or name placed within single quotation marks. Our example including the cultivar would be Prosopis glandulosa cultivar Maverick. Hybrids are crossbred plants with their names conjoined by X between the botanical names and the hybrid descriptor or name, which is designated by single quotation marks. The plant's common name is often used for hybrid names. Our example of the honey mesquite tree with a hybrid would be Prosopis glandulosa hybrid South American. Plant names are typically abbreviated using the first 3 letters of each part of its botanical name. However, common names are often abbreviated as well. One method of categorizing plants is by the type of seed used for reproduction. Seed-producing plants are either angiosperms or gymnosperms, and they have very distinct traits and characteristics. Angiosperms are the flowering and fruit-producing plants which make up 80% of all plant life. The plant embryo, or seed, is contained and protected within the fruit, which is often spread to new areas and regions by animals. This cooperation with animals has contributed to the angiosperm's success and dominance among plant species. Within angiosperms, a plant can be categorized as either monocotyledons, commonly known as monocots, or eudicotyledons, also called dicots or eudicots. These terms refer to the cotyledon, or embryonic leaf portion of a seed. Seeds with single embryonic leaves are monocots and results in full-grown plants that have fibrous spreading roots, long narrow leaves, parallel leaf veins, and flower petals in multiples of 3. Dicots are from seeds that have 2 embryonic leaves. As full-grown plants, dicots have a central tap root structure where other roots branch out from, which allows dicots to typically grow larger and higher than monocots. Dicots will also produce wider leaves and have a reticulate network of leaf veins, and flower petals will be in multiples of 4 or 5. Gymnosperms refer to seeds producing plants that produce their seeds without the protection of the ovary or fruit. These enclosed or naked seeds develop on the surface of scales or leaves, which often form cones. Pollination of gymnosperms is mostly dependent upon the wind. Almost all conifers are gymnosperms, but cycads and ginkgo also belong to this group. Leaves are the most defining trait of a plant that can be used to identify its species, because leaves vary greatly from plant to plant. However, certain aspects are common among all leaves. Leaves are supported by the structural axis of a plant, which is called the stem. Nodes are the points on a stem where the buds, leaves, and twigs originate. Leaves are connected to the stems by the petiole. The petiole transitions into the midvein, and secondary veins branch out from the midvein. The leaf tissue or membrane is called the lemony, which is also referred to as the leaf blade. Leaves are considered as either simple or compound. A simple leaf has a single leaf blade formed around the petiole. A compound leaf has multiple leaflets that extend out from the rachis. The arrangement of leaflets on the rachis leads to the classification of different types of compound leaves. These different types are pinnate, double or twice pinnate, palmate, trifoliate, and ternate. It is sometimes difficult to know the difference between a leaf and a leaflet. All leaves, whether simple or compound, will have a bud node at the place of petiole attachment to the stem. Compound leaves have a bud node at the base of each stem or petiole, but no bud node at the base of each leaflet and the rachis of a compound leaf. Leaf shapes can vary considerably. Some are very distinct and defining, such as a maple tree leaf. The most common shapes are oval, truncate, elliptical, lanceolate, and cordiform. The leaf edge can be a very defining trait of a leaf that is useful in identifying a plant species. Most leaf edges can be considered as either lobed, scalloped, toothed, which is also known as serrated, or entire, which is also known as smooth. An oak tree leaf is an example of a lobed leaf edge, while an elm tree leaf would be considered toothed or serrated. Leaf arrangement is determined by how many leaves emerge per node on the stem. Plants with alternate leaf arrangements have one leaf per node. This makes the leaves look like they are staggered on the stem of a plant. Some examples of trees with alternate leaf arrangements include birches, sycamores, and willows. Opposite leaf arrangement means that the plant has 2 leaves per node, growing in pairs directly opposite from each other. The leaves of ashes, buckeyes, and elders exhibit opposite leaf arrangements. When plants have whorled leaves, this means that 3 or more leaves grow from a single node. Southern catalpa is one example of a tree with whorled leaf arrangement. Herbaceous and woody plants are 2 categories of plants based upon the types of stems, trunks, and branches that the plant has as its vascular and support system. Herbaceous plants have soft, flexible green stems, which means that their support structure does not allow for tall growth. Their stems die back to the ground level at the end of each growing cycle. Herbaceous plants include most perennials, grasses, and some shrubs. As the name implies, woody plants have hard and rigid trunks and branches that are covered with bark. Woody plants have the support structure to grow to great heights. Their trunks and stems persist above the ground during winter and from season to season. Woody plants include trees and most shrubs. The proper plant selection will make the difference in whether a plant thrives or not. Choosing the right plant for the right space will result in healthier plants, reduced water use, and reduced maintenance. Plant selection is the organized process that examines several factors such as hardiness, water demand, sun exposure, size and structure, growth rate, and microclimate. Hardiness is the measure of a plant's ability to withstand cold winter temperatures. The U.S. Department of Agriculture, or USDA, has defined plant hardiness zones, which offer 10 fundamental classifications across the country to assist in determining which varieties of plants are best suited for their environment. The zones are defined by a 10-degree Fahrenheit difference in the annual minimum temperatures on average, and the A and B segments indicate a 5-degree Fahrenheit difference between them. Areas with warmer winters have higher zone numbers, and areas with colder winters have lower zone numbers. If plant selection is made that matches the hardiness zone, the plant should be strong enough to survive the winter temperatures in an area. Colorado is known for its diverse climate and unique geography, which results in a wide range of plant hardiness zones. The state is divided into plant hardiness zones 3A to 7A, each characterized by different temperature and climatic conditions. However, there are exceptions for the microclimate of a site. A valley floor could be up to 10 degrees colder than a site on a nearby mountain or hillside slopes. A north-facing slope may be much cooler and damper than the dry, hot location on a south or western-facing slope. Plant hardiness zones are a good guide, but local conditions play a role and need to be considered in determining plant selection. Plant water needs vary depending upon factors such as plant species, size, age, local climate, and soil type. Not all plants have the same demand for water. New and young plants require water more often as they have shallow, undeveloped roots and tend to dry out quickly. Mature plants tend to be more drought tolerant. For an established landscape, watering twice a week is considered an average water use expectation. More than that is considered ample watering, while watering only once a week will leave a landscape dry. Xeriscaping is a term derived from the word xeric, meaning low water, to describe an approach to landscaping that uses minimal water and requires little maintenance. The type of soil is another important factor. Sandy soils drain water quickly, requiring more frequent watering, while clay soils retain water longer, requiring less frequent watering, but could also lead to rot if there is too much water in the soil. Plants require sunlight for photosynthesis, but for some plants, too much sun can dehydrate and damage their leaves. There are plants for every type of sun exposure. Some plants require full sun, while others prefer partial shade or full shade. Full sun exposure is considered as 6 to 8 hours or more of direct sunlight per day, and this is common for south-facing sites. Many flowering plants and perennials, such as asters, daisies, and coneflowers, thrive in this full sun exposure. Partial sun or shade exposure will receive 4 to 6 hours of sunlight, either direct or dappled throughout the day. These are the east and west facing locations that receive morning and late afternoon sun. Columbine, hydrangea, and coleus are examples of plants that do well and partial sun exposure. Locations that receive less than 4 hours of direct sunlight are considered full shade, which is typical in the north orientation of a site. Hostas are an example of a shade-loving plant that favors full shade conditions. Plants exhibit an enormous range of sizes and shapes. Common shapes include the conical form of conifers or the vase shape of many shrubs. Landscaping plants are measured by height and width when they are fully grown. The width is the same as the plant's spread, which also indicates the extent of the plant's roots below ground. Plant selection must be based upon a plant's full growth potential so that the plant does not become overgrown for its location. Plant placement should consider a layered tiered approach with tall plants placed in the background, medium height plants in the middle, and shorter plants in the foreground. This fills visual voids in the understory and creates visual interest and depth in the planting area. Since trees have a canopy that begins several feet off the ground, the area beneath the canopy can also be considered for smaller understory plants. What distinguishes landscape architecture from all other design disciplines is that they work within a palette of living materials on a canvas of time. The product of their design efforts is a biological imprint that grows and changes as time goes on. The realization of the landscape architect's vision may only be experienced years after the project is complete. Even within the cycle of a year, the landscape is constantly changing. Plants experience an annual growth cycle. Spring is marked with blossoms and buds, and autumn is filled with vibrant, changing leaf colors. Growth rates vary among plant species, and plant selection may consider the various states of a plant over time. Fast-growing plants, or annuals, may be used while slow-growing plants take time to establish and develop. A combination of flowering springtime plants and bright fall foliage plants may be selected to provide a vivid, colorful landscape all season long. A well-designed landscape is never the same and will provide a rich variety of experiences at every visit. Microclimate is the local climate of a small area, influenced by factors such as soil, sun, vegetation, topography, wind, and bodies of water. But it is also strongly influenced by the built environment of buildings and pavement. Plant choices can be tailored to the specific conditions of the microclimate, which can vary from the site's hardiness zone. Plants are not only selected to be compatible with the microclimate, but also to influence it. Trees placed within parking lot islands is one such example of providing shade to counter the effects of solar heat being reflected off the pavement surface. Dense groupings of plants can function as a windbreak to filter the wind and create calm and protected sites. Plants have a vital role in shaping microclimates, affecting temperature, humidity, and wind dynamics of the local site conditions. Landscaping plants are typically categorized by their use and purpose rather than by anything scientific. These common groupings are ground covers, annuals and perennials, vines, grasses, shrubs, and trees. Most nurseries will group plants in this manner, which make it simpler for those who are not keen on the subtleties of the biological traits of plants. We'll go through these different types of plants, what traits are common within each category, and describe where they are useful in a landscape. Ground cover is a type of plant that grows over the surface of the ground and does not gain much height. Their growth tends to be more horizontal than vertical. Ground covers are important in providing protection of the topsoil from erosion and drought. Their root system forms a vast web within the upper layers of the ground, which stabilizes and locks the soil in place. Ground covers absorb sunlight and can reduce the surface temperature of the ground. When most people hear ground cover, the typical response is to think of turf grass, but there are many varieties of ground covers, including those that flower and have rich color and texture. Some alternate ground covers include common periwinkle, creeping phlox, and rock cotoneaster. An annual is a plant that completes its entire life cycle within a single growing season. In landscaping, annuals typically refer to flowers such as geraniums, petunias, and marigolds, but most gardening plants such as tomatoes and beans are also annual plants. Annual flowers in a landscape offer the benefit of vibrant colors all season long with seasonal variety that can be changed from year to year. Perennials are plants that have a life cycle spanning multiple growing seasons. Over 90% of plant species are technically perennials, but the term commonly refers to smaller herbaceous plants and flowers that are used in a landscape. Perennials grow and bloom over the spring and summer, die back every autumn and winter, and then return in the spring from their rootstock. Perennials can provide a variety of color to a landscape with longevity and reduced maintenance in not having to replant each year. Some common examples of perennials are blanket flowers, daylilies, and asters. Vines are plants with a growth habit of trailing or climbing stems, lianas, and runners. Vines climb, either naturally or through training, by coiling tendrils that attach to structures such as a stone wall or trellis. A twinning vine, also known as a bine, is one that climbs by its shoots growing in a helix pattern in contrast to using tendrils. Vines can grow in both deep shade and full sun, making them a very versatile landscaping plant. English ivy, clematis, and honeysuckle are common landscaping vines. Often referred to as ornamental grasses to distinguish from turf grass species, grasses make excellent visual accents and add texture to a planting area. Unlike turf grass, ornamental grasses are meant to be grown and not to be mowed. In fact, ornamental grasses are very low maintenance landscaping plants. Grasses have growth habits that are either clumping or spreading. Spreading grasses expand rapidly by above ground or underground stems. Clumping or bunching grasses grow in a clump that gradually increases in size. Shrubs are grouped as either being deciduous, which means that the plant will drop its leaves at the end of the season and will grow new ones, or as evergreen. Most people think of evergreens as plants with needles instead of leaves, but there are broadleaf shrubs that will keep their color all year round, such as boxwood and holly. Shrub sizes can range from being a ground cover plant all the way up to being a small tree, which is why shrubs are also grouped into a range of sizes. Small shrubs are considered those that at full growth will have a height and spread of 2 to 5 feet. A medium-sized shrub will be in the range of 5 to 10 feet. Large shrubs are those that tend to grow more upright and have woody stems, since these can grow to be over 10 feet tall. Trees will also be either deciduous or evergreen, but deciduous trees are grouped as either shade trees or ornamental trees. Shade trees are large upright trees that have a large spreading canopy that casts a shadow from its dense leaf clustering. These are used extensively in urban environments to counter the sun's reflection from buildings and pavements that leads to a heat island microclimate. Ornamental trees are much smaller and do not have the height clearances under their canopies to provide shaded areas that can be utilized by people. However, ornamental trees offer vibrant colors and visual interest to a landscape. Ornamental trees, such as the crabapples, produce brightly colored blossoms, fruit, and leaves that cycle throughout the growing season. As the name implies, evergreen trees contribute to a landscape the whole year long, but it is more than just their color that brings benefit to the landscape. Evergreen trees are excellent for filtering the wind, and they are a must for any windbreak. They also contribute to reducing the noise from adjacent sites. Due to their conical shape and branches starting just above the ground plane, evergreen trees provide excellent visual screening of undesirable views. Landscaping plants are grown in fields, but are transported to nurseries until they are purchased and ready to be transplanted into their final location. Plants can be uprooted while they are still dormant, typically in early spring before the start of the growing period, and transported with bare roots exposed without any soil. This method of transporting bare rootstock is cheaper since none of the weight of the soil is included in the shipping. The roots are wrapped or bagged with sawdust to keep the roots from drying out. Bare rootstock has a limited window of time for planting and may take longer for establishment. A more common method is for plants to be shipped with their roots and soil placed in temporary containers. Containers make for easy transport, and they provide less fragility than bare rootstock. Container plants can usually be carried by 1 or 2 people. For very large plants, the only method available for shipping and transport is to excavate the plant's root ball with soil and wrap it with a burlap material or wire. This is referred to as ball and burlap. Plants packaged in the ball and burlap method are often too large to move without the use of equipment such as a forklift. The size and maturity of the plant is represented by the size of the container. The larger the container, the larger the plant that is within it. The convention used in the eastern part of the country was that the container's diameter defined its size. In the West, containers were defined by their volume measured in gallons. Due to these variations, the American Standard for Nursery Stock, ANSI Z601, developed standards for the measuring techniques of nursery plants. According to the standard, the size of a plant container is determined by its volume as measured in cubic inches or cubic centimeters. Plant containers are considered a certain class number when they have volumes that are within the determined range of the standard. The American Standard of Nursery Stock also defines the standard for the size of shade and ornamental trees, which is a measurement of the width or girth of its trunk. The instrument used to gather this measurement is called a caliper. Therefore, the size of tree stock is referred to as its caliper. The caliper measurement is taken 6 inches above the root flare and is recorded in half-inch increments. The tree root ball is approximately 10 to 12 times the size of the tree's caliper. A rule of thumb is that the tree caliper measurement in inches is equal to the root ball measurement in feet. Evergreen trees are not measured by the trunk caliper. They are instead measured by the tree height from the ground plane to the top of the tree, as indicated in ranges of 1-foot increments. Proper planting is important to ensure the establishment and survivability of a tree or shrub. The width of the excavation pit should be 2 to 3 times larger than the diameter of the tree root ball. However, the pit should be no deeper than necessary for the root flare of the tree to be 1 to 2 inches above the finished grade. The bottom of the pit should be undisturbed subgrade to provide a solid base for the tree without settlement. Ideally, the bottom of the pit would be crowned so any excess water drains to the edges to keep the root ball from being immersed in water, which could cause rot. The backfill around the root ball should be nutrient-rich soil material to encourage root development and establishment. This material could either be potting soil from the nursery or soil amendments mixed in with the excavated soils on site. Once a tree is planted, it will likely require staking to support it and to keep it straight against the wind. A strong wind can blow over a newly planted tree that hasn't yet established its roots. It usually takes a full growing season for a tree to grow sturdy roots, so stakes should always be removed no later than a year from the time of planting. Guide wires can girdle and damage a trunk if left in place for too long. Staking left in place for more than a growing season can lead to poor trunk growth and weaken the tree. Mulching around plants provides several benefits that contribute to establishment and healthier plant growth. The primary reason for mulch is that it helps retain soil moisture and helps keep the plant from drying out and requiring frequent watering. A thick layer of mulch will also suppress weed growth and will reduce maintenance. For the same reason that mulch keeps weeds from growing will also affect landscaping plants, so it's important not to cover plants with mulch and to keep mulch away from trunks a minimum of 3 inches. Mulch can be either organic material such as wood chips and shredded bark, or it may be a mineral mulch like riverbed gravel. Rock mulch is preferred at locations of heavy water runoff since wood mulch is easily washed away. The topic of the effectiveness of weed fabric barriers is a subject of continuous debate. It often comes down to the designer's preference. If a weed fabric barrier is being used, it should be anchored to the ground with pins and staples if organic mulches are being used. Mineral mulch will function as a ballast weight and will suffice for holding the weed barrier fabric in place. This concludes this TK Academy course on landscaping plants. Hopefully you enjoyed this course. If you did, please give it a thumbs up and leave us a comment. You may also want to subscribe to our YouTube channel for more courses like this and other content from TK Architecture.